years helped us determine, given us tools to help determine what makes a concrete, how can we define concrete as quality or not. And so before I jump into that, I just wanted to give you a quick little idea about what who ACI is and what they do. They started in 1904, not just a trade organization of a bunch of concrete guys getting together. It's not a lobby group that goes to Washington and tries to get everything built in concrete. It's different than that. It's industry-wide, nonprofit, charged with furthering the technical knowledge of concrete that we've been using all over the world for centuries. So it involves research and development of concrete materials, technical parameters for concrete uses, and it's a forum for educating people on what they can do with that. The organization is made up of designers, and this is kind of the key. It's really, truly a cooperative effort between industry partners. Designers, engineers, and architects. Researchers from academic settings, specification and code writers, material producers, suppliers in the concrete industry, government interests like public works agencies, the Corps of Engineers is involved, and of course trade contractors like Morley Construction. And just as a side note, one of the privileges I have in working at Morley is we support ACI because it's a core part of our business, and so I get to participate in some of the developments and things like that that are happening at ACI. It keeps us on the cutting edge of what's happening in concrete. So what I want to share with you today is kind of like Mark's giving you the experience side of it, 30 years, 40 years perhaps in, well, 15 years, I don't want to date you, Mark. Lots of years in construction, in concrete, knows how it works. My background is from the office side of it. 10 years in our LA office and another 10, about 10 down here in San Diego, all with Morley. Before that, worked as a structural engineer, designing some things, but decided, concrete is really where it's at. It's smarter to be involved with actually building things than designing them. But ACI puts together this group of people on technical committees, and one of the things this morning, or this afternoon, that we want to talk about was, from our perspective, how do you decide what is quality concrete? And one of the latest things they've put together is how to determine concrete, quality concrete that's for form services. To start with, many of you know, I'm not here to talk about the F number system, but hopefully you're aware of that. That's been out for a little while. F numbers were created to give an objective means for determining quality in terms of flatness and levelness, right? Flatness being bumpiness, levelness being in pitch, left and right. Those are found in ACI 117, tolerances for concrete, and ASTM has a test that defines how you determine what an F number is. So that gives you an objective way to look at a quality surface that's been finished by laborers, what we saw D&D doing. You can look at a quality finish, and it couches it in terms of flatness and levelness, which is pretty objective when you do the math, and you can figure that out. It's not what we're here to talk about today. What ACI recently did, and this is through their 347 formwork committee, is try to establish a similar criteria for formed surfaces in concrete. So what F numbers did for floors, we have something called concrete surface categories now, as of this last year, that are used for determining quality of a formed concrete surface. And if you've ever been on concrete jobs, this is one of those things that's been a thorn in everyone's side for years and years and years. How do we know if this concrete, when I pull the forms off it, is the quality that we ordered or the quality that the owner paid for? And so ACI is in the last 3 or 4 years. I'm fortunate enough, I'm an associate member of 347, so the stuff you're going to see today is from their latest publication. I've got it listed up here. You'll be able to get it off the slides. 347.3R-13 was produced in 2013. But I'll give you some of the insights that I have from that process that happened over the last couple of years and where they're at today with that. So after publishing that, they've basically come to look at what are the measurable properties pertaining to formed concrete surfaces. And so in chapter 3 of this section, it's only 20 pages long, so it's not that big of a thing. You can buy these sections, you can buy these pamphlets, individually through ACI if you need them. But there's one. Chapter 3 is probably the key chapter that talks through what are the properties of concrete that we can look at and objectively measure, so that we don't have this argument every time on every project. Hey, it's good enough for me. It's not good enough for the architect, but the owner says I just want to be done with it. So these are the categories they're looking at, the variables I should say: texture, surface void ratio, color uniformity, surface irregularities, construction and facing joints, mock-ups, types of form, facing, and then the relative costs. And they put those together on a chart. I just wanted to quickly today, again, not wanting to dump a whole lot of concrete details with you, but if you're involved with concrete projects, it's good to know that this is out there. So I just wanted to quickly jump through each one of these, what they are, and then open it up for questions at the end if you want to get deeper. Happy to do that. So the first one, texture, concrete texture. They've categorized it in a variable called T1, being not very good texture, to T4, which is the highest level of concrete textures. And textures are things in from the T1 level, acceptable gaps in an adjacent formwork up to 3/4 of an inch. Things like that. Allowable projections 1 inch from adjacent surfaces, if you can imagine. This is like footings, things like that, where you get all the way up to texture on 4. The surface of the concrete has formwork should be grout tight. There's avoid grout mortar leakage and correct where it occurs. In other words, if you see leakage that comes out, if you've ever seen a concrete surface when you pull the forms off at the seams, you see a little aggregate in there and sand, where perhaps the paste has leaked through the form during the process of placing it. And so you see those voids in there. Sometimes they're large and they're called concrete voids, or you've got rock pockets. But even at the seams, there's a little leakage, and you see like a sandy version of that. So that project that Mark was talking about, that was unacceptable. That's a level where they wanted to see the texture of the surface at the T4 level, if you will. And so ACI has put together a chart that describes each one of these levels for texture. And it gives you a description of each and a table that tells you what to expect in each one of those. So you can look at the texture. Surface void ratio. This is another fancy academic word for bug holes, or we see in concrete all the time. And take a look at this column, for example, here. This was on a project at Qualcomm, and anything that was less than, I think it was a 1/2 inch, 3/4, they were fine with. And architects, and this just goes to the whole question. Some architects want to see texture. They want to see. They don't want to see something like it looks like it was produced in a factory somewhere and just spit out plastic. They want to see some variation in the coloring and things like that. And so each one of these categories as we go through, it gives them an option to say, I want an SVR1 or I want an SVR4. If I go down here on my chart that I've got here for the surface voids, it just is basically talking about a 12-inch square. They put a 12-inch square up. You can actually physically measure this. Put a 12-inch square tape, count the number of holes or voids that are occurring within that square, and if that number is between this, it's an SV1. If that number is higher, the fewer there are, the higher the number. So the SV4 is the least amount of bug holes. SV1 is the most amount of bug holes. But at least now there's a test, so that you can objectively measure something out with an owner and say, this falls under category SV2. And whether the owner bought that or not at the beginning will be up to the spec writer. And of course, the reason we like to have times like this to talk to general contractors is, so that beforehand, when we're in the pre-construction process, we can talk to owners about this, and we can go down and try to say, what do you want? Do you want this amount of bubble? Do you want that? What level do you want? And so that can be worked out beforehand. And at least at this point, it's no longer subjective.
How much of this is showing up now in specs and in projects?
Like I said, it just was produced last year, this last year, 2013, and it took 3 to 4 years to get through committees. I'll get to some other interesting things at the end. So you're just starting to see it, sort of like in the early, 2000s when people were taking F numbers and people scratched their heads and said, I have a straight edge and it's 10 feet, and don't I just go measure something underneath it and figure out how flat your concrete is? And no, what is the F number? So there's going to be a little bit of lag before you get this, but we'll get to the end and you'll see I think that's part of our process of just being at the cutting edge of concrete. We now can come to the owner and say, I know exactly, it's protection for not just the guys in the field and the Morley Constructions of the world that are trying to produce something, but for the general contractors, to be clear with the architect about what they're buying. and not have the arguments come up again, so everyone's kind of.
Is there a percentage of the job that you test?
Pardon?
Like a percentage of the job? I mean, do they just go pick like the worst spot?
So what you would do with
best
this,
spot, or
what you would do
10%?
with this, the architect would say, I want architectural exposed concrete on my walls, and I want it to be at a level SB2. And so anywhere you're exposed, you could probably, you'd have to take this size taped area, and you should not find below that many. And what's the solution to that? It's a very simple solution, and you just start, filling over some of those. If it gets to be large areas, it can be a problem, but, at least we know going into it, we better make sure that the formwork that we use is not trapping air on the surface. So when we pull the forms, we're gonna have a ton of these. And we can talk through that with the architects beforehand and work out what they're expecting. So yeah, there's a way to, and it's not just, hey, I found this one that's big. It's so many percent in a given area, and that area is defined.
That's why we do mock-ups.
Mock-ups is one of them on the list here, and they talk about mock-ups too. So that's that one. Color uniformity, a couple of pictures here. I tried to find some that had, some variations in color uniformity, just to give you an idea of what those are, right through this area. But that's usually between pours, or lift lines, sometimes people call them big walls, right? If you're pouring a wall and the truck or the pump's pumping down, it's filling up the wall to a certain level, you get to the far end, you come back, it's filling another level. In between time, that concrete has sort of settled already, it maybe starts to set up. Hopefully it does. A lot of times the formwork's designed based on the fact that it's going to set up, it's not a form of pressure. But that concrete comes back, and it's, 10 trucks later, 5 trucks later, however many there are in the sequence, mixed from a different batch of aggregate that's keeping batched the plant. There might be a color variation in that concrete just based on the fact that it's not the exact same aggregate part of the pile of the aggregate that was pulled from the batch plant in the morning. So there are some natural variations, and part of that's just the uniqueness of concrete, and that's what people like when they want exposed concrete. They want that non-homogeneous look, but it can get out of control, and we've all seen that. You use, maybe they batch from one plant, and then a truck comes from another plant to pick up the rest of it, and you get really significant differences between concrete on one wall, and the architect says, that's not what I bargained for. So there's a way to define that. They only put 3 categories in for color uniformity. I don't know why. It just seemed like it's probably more difficult to define, so there's like a medium, large, small, medium, large type of approach that you're either close or not. But they defined it here with light and color dark variations acceptable under C1. Rust and dirt stains are acceptable under C1. So there's a category for that kind of stuff that happens, and we've seen that all on projects. And an architect or an owner may be fine with footing concrete or some concrete somewhere that has stains coming off the top of it. And so there's a category for that, all the way up to CU3, which the discolorations caused by concrete source material of different type and different origin are the only types of variations that you should see. The rocks are slightly different, but it's in that same area. So that's color uniformity. Surface irregularities, SI1 to SI4, again, 4 categories for that. A lot of this is sort of objective and has always been in ACI 117. These are the offsets in formwork. If your formwork during the pour deflects slightly and there's a small gap or a 3/4 gap, they used to have Class A, Class B, Class C, 1/8 of an inch, 1/4 inch difference, 3/4 of an inch difference. Those kind of offsets and differences are measurable, and they're pretty straightforward. So if there's an irregular section of the surface where it's not homogeneous, it's not straight flat, it bumps up, you just measure that and you can decide, depending on how large that difference is, on what level of the surface irregularity variable you're at. Okay, so there's that, and then there's construction and facing joints. These are joints between types, between pours at construction joints. And when you pour this, there's a break in the wall, a bulkhead in the wall, let's say, and then you come on the next 3 days later and you're ready to pour up against it. How is that joint and that connection supposed to behave? It's different than the quality of your formwork seams. That's a little bit different situation. So they've provided four categories for what would happen or what you can expect with different levels between your concrete joints. That's a little bit more of a difficult one because it depends on what type of material you use. And recognizing this, ACI has gone through and they talk about form facing then. I mean, you open a can of worms when you start talking about the joints. And remember, I'm talking about an organization that's made up of material suppliers, architects, engineers, and formwork suppliers are certainly a part of that. So in these national committees, where they're deciding about what constitutes a good joint between two pours of concrete, the metal formwork suppliers say, hey, we want it perfect because metal forms look like they're expensive, they're heavy to work with, they cost a lot of labor, but they give a nice, flat surface, and they rarely have these irregularities. So those types of folks, just from their background, will want to expect something higher. So between these last two categories on what to expect on those joints, and also the form-facing categories, FC1 to FC3, you get a lot of debate, and that's what takes the most time to get these things through the committee on, something that everyone can agree on. So kind of in helping this process go forward, one other useful process that went on and is part of the 347 committee is a chart. I'm going to go ahead a couple spaces before we talk about mock-ups, just to kind of show you this. Probably not, well, it is a little bit visible. So there's a chart, 4.6.4 in this section that lists out different types of form-facing materials. Everything from normal lumber plywood all the way down to steel forms, fiberglass, phenolic forms, coated plywoods, and they sort of, as objectively as a group of industry people can, have listed what you can expect in terms of texture, rough wood grain, and visible defects will show up if you use unsanded plywood or plywood with similar properties. These are absorbent materials, and they've broken them down to non-absorbent materials. So there's a list here. I didn't put the whole chart on because you get dizzy, but the top section and just one section from the bottom I've used here just for example. They give you an approximate number of reuses. You can expect 2 or 3 uses with something just raw plywood that's going to soak up concrete. It's readily available, so they give you some advantages. They give you a couple of things to think about. And again, this is primarily for people on the architect or design side before they spec something, so they can have a better idea about what they can expect if they say, hey, use any kind of plywood you want. This is what you may have. All the way down to the bottom where you get into, this is non-absorbent or semi-absorbent and laminated paper tubes, metal-faced forms are non-absorbent, obviously. No texture grain. There's no grain read-through on metal forms, right? You can expect to see some type of rust stains. You can, repair needs welding. You need to, when you repair a steel form, you got to weld it, and you might get some patching parts that'll leave, stains, rust stains, possibly other stains on the concrete. But you see, you've got maybe 100+ uses. They just kind of limited it to 100 uses in here. So the metal form work guys are really happy about this. This is what they want to make sure. Hey, you may say it's more expensive, but make sure you tell everyone that you can use it a lot. So that's part of that whole process that comes up with what kind of form face. So if nothing else, the form facing material chart is pretty useful for architects. They put together that category for that reason. And then of course, like you mentioned earlier, mock-ups and relative costs. We talked about they have relative costs along that chart to tell you what is more expensive and less expensive. They don't want to give you prices, of course, because they change, but relative to each other, they've kind of stacked up different types of formwork. They do make a pretty big point to talk through shop drawings and talk through mock-ups, and recommend that at any level of the concrete surface categories that are higher than that 1 or 2, that you really need to have a mock-up. And it has to be done in similar site conditions if you want to see what you're going to end up with. So all those variables that we just talked through, they all comprise of the kind of like the Rosetta Stone of this whole process that they work through is this last chart, where they come up with the CSC categories 1 through 4. Simple, just 4 categories for concrete surface categories, and it looks like this. And so they've got on the left-hand side here, basic requirements, CSC 1. What kind of texture do you want? Do you have in there? T1, the form surface voids are here, the color uniformities are at 1, surface irregularities are there. You probably don't need to do a mock-up if you're doing that. It's really low cost, and the form-facing category should be FC1. So that's kind of the very basic level, all the way up through these, SC2, CSC2, CSC3, and CSC4. And so they talk about these two, CSC3 and 4, having special requirements. You may want to be at a level T3 in here. You may want to have your surface void ratio be at 2 or 3, depending on whether you're absorbent or non-absorbent material. They highly recommend a mock-up in this one. And for the CSC4, they're saying it should be required. No doubt about it, you should have it. So as far as an organization that's put up together by people across the industry, across the nation, putting together a tool that you can now use, this is really helpful. This is the kind of thing that you can walk in and next time you have a project where an owner or an architect wants to do exposed concrete, you can at least come up with some objective criteria about what you can expect. Then when bids come in, when contractors start looking at drawings, they get an idea of what they're going to need to do and how they're going to need to price what's going to be produced on site. So that's kind of a taste of what I wanted to let you know that's happening in ACI and with the concrete industry in terms of quality. It's always a big issue. It's sometimes, because it's new, I thought it'd be interesting for you folks to hear about being involved in pre-construction jobs like that. That's kind of all we brought, just our subs perspective and some trends in formed concrete surfaces. Any questions on any of that, feel free to either ask us now or shoot an email over and anything come to mind. Awesome.
That's the way you like it.
It might be a lot of information. It's a lot of information to receive from us as well. So, but yeah.
With this new system coming out, do you guys have a lot of owners and contractors asking about it?
A lot of times it's the spec writers that start out.
Okay, pushing it on them.
And then owners will be asked if the spec writer is knowledgeable about it. And the architects, engineers not so much, but mostly architects and spec writers and designers will be the ones that say, hey, I know I want concrete looking like this, what do I do? They go to ACI for that spec section and they say, oh, if they're pretty savvy with it, they'll figure it out and they'll get to a chart like this and they'll put it in the specs and then we can talk through it. But it is, because it's new, a lot of those people have been doing, like all of us, the F number system. How long you've been, it's been in place for a while, you just do it the way you did the last job and you know how that works. So it's hard to kind of get it out all at once. It'll take some time before people are familiar with it. But like I said, it's produced now, it's published, and it's a published document base, yeah.
So I guess part B to that question is, do you guys ever offer that specs? If they're not using it, they're required.
Oh, yeah.
You guys, is it a benefit to offer it, to say we should use this? And
Absolutely. I think before this was even published, we all in our own way, concrete contractors in our own way, have been trying to talk through these issues and say, well, how much sacking do you want? What's the building you want to match? So a lot of times we're just matching buildings to try to understand what this is. But before this was published, the last couple of years, Morley's been using, because we kind of knew that it's coming down the road, we've been using sort of categories like this to talk through with people and say, we want an objective way to look at what you can expect. Here's one way to look at it. So I think it's just going to become more present as we go forward. And you ought to be thinking about it. I mean, if you do have an opportunity, it's there. It's now. It's like ignoring title 44. Before it comes, you can kind of think about it. But at some point, someone's got to be aware of it and incorporate it in the work you're doing.
How about self-consolidated concrete? I mean, you're doing a lot of structural walls. It's expensive, but does it minimize this and give you a better finished product?
Yeah, so it's part of the definition. If you think that's quality, homogeneous, nothing, flat, the guys who did that Qualcomm building we do, the architects, would not have thought they wanted that. They don't want something looking like it was manufactured somewhere. They like the variation. So they may not want something like that. But yes, self-consolidating certainly addresses a lot of those issues and gets you further down the category.
Are you utilizing that much?
We're not using a lot of it here, and most of it's due to the suppliers in San Diego don't really have a demand for it, so they haven't produced it, they haven't figured out how to get it done economically. So we've asked for it a number of times, and I think some of them have used it here, actually on your airport job, and in the, the main tower, Terminal 2 towers, the columns, they use some. Yeah, so that was used. I know the local supplier put together a mix for that.
Right.
We're anxious to kind of try to use that maybe in some other areas that
Right.
we'd use it if it saved money,
Right. They
right?
went through several mock-ups.
Yeah, yeah.
Yeah, it's sporadically used locally. I mean,
Yeah.
for 5 years ago, we were doing mock-ups, you know, in conjunction with some of the suppliers, that, you know, 'cause you read about it across the country, and, you know, it seems to have benefits of it. And I know they've done some Caltrans work, and then
Yeah.
these pieces down here, but it's, and I know like the precast box builders that do
It's
catch
perfect for that.
basins and electric, you know, electric
Precast.
vaults, they all use it, but.
Because you have a controlled
Yeah, it's
environment.
And it's
and-
small with a lot of steel,
Right.
and
Yeah.
a lot, you can't get
I
away
mean,
with
you
it.
can do that at a batch plant somewhere or a precast
Yeah,
plant and
control
take
the
control of it. Here, you've gotta ship it somewhere, depending on where the project is, and it's in the truck, you gotta make sure you're shipping,
And you gotta pump it out.
you're gonna pump it and it gets
All
more
that fun
complicated. You probably know. So, yeah, good question. Anything else? Yeah, good. Well, thanks for having us.
All right.
Thanks.
You know, I have to say one thing about Morley and the Central Library
It really
Project.
is. It takes the.
One of the things, I got to do 8,000 tours with Rob Quigley, who was the architect for that project. And he loves art, he loves the feel, the look of concrete and exposed items throughout the whole project. And one of the things, the next time you walk through the library project, I want you to look at the concrete actually, and take a look at the patterns that you're seeing through all the columns and all the walls and how they are unique. They're not the same, okay? The column itself might be identical to the next column, but the pattern that you're seeing on it is not. And that took a lot of time and a lot of effort and a lot of coordination and a lot of logistics and a lot of planning, not only for them, but out in the field. We actually had these column forms numbered, and they would flip them, and they would do all kinds of different things to create these numerous different patterns. And in walking with Rob Quigley, he would always talk about the design of things and stuff like that. And then it was funny, I would walk with him, I'm like, and look at this concrete art is just amazing, okay? And I would show out some of the stuff which he loved, and he would then expand on it. And it truly is, the structure itself is part of the art of the architecture of that whole structure. So if you look at it from that point of view, next time you're walking, it's amazing to actually see the little details that these folks put into play in that structure. You know, the quality is just there. It's amazing to me now to know all these different specs. I didn't know all of that. So that was something that I really learned. So thank you very much for coming out. See these this is what I'm talking about. Okay, all of these patterns everywhere. Okay, and all these columns is all unique and all different. And it was one of those things that was just an amazing process to go through, and to hear him talk about that. I mean, there's a lot of other details in here. When you really start to learn about this arch and what it actually does and how it's only connected by this one little piece up here, and this is not actually connected, it's free floating, and you actually understand all that, it's really amazing.
Yeah,
Okay.
it was an amazing project, and like I said, that architect, he likes this. The guy in Malibu would have hated that
Yes.
pattern.
Yes. And that's what I'm saying, oh yeah, the guy with the $20 million house would have been like, what are you doing? Okay.
Yeah.
But two different looks, so they had to listen to what was actually
Right.
wanted
Right.
and then put it into play. And that was one of the things that I really loved about working with them here. Another thing on the safety side of the house, Morley truly, it has become a leader in, I want to say, elevated work surface, nothing hits the ground, and creating those engineered aspects of what they do. D&D even had a picture of something that these folks created to make it safer, better, and more effective for the folks out in the field. They're future thinkers in regards to that. And with our push on innovation, it's one of those things that we're really trying to push into a lot of other trades and throughout all of our other projects. So I actually applaud you guys in regards to that innovation, because I've seen it in use. You know, and it really does make a difference, not only to your folks, but to the whole project as a whole. And the safety record there proved it. It speaks for itself. I don't even have to say anything, you know. Any other questions, comments for these guys? Otherwise, I really am grateful for their time. Okay, thank you very much. This presentation I already have sent to Richard and will be uploaded on our SharePoint site as well, so that you have that. Matt, anything else for this crew?
No, I think that's it, pretty much it. Just, working with your guys early on, like Mark said, getting the whole forming system down, type of concrete, the end use of it is really critical to work with these guys in the beginning, to know what you're gonna be building in the long run to the end, to come to one, complete product for the owner plus for yourselves. So it's really critical to get into the early stages, as Mark was saying, to get things all set up logistics-wise and for the forms and everything else, what you're gonna be doing.
Yeah. Logistics on the safety side, is huge. The whole traffic control, like Mark was saying, downtown, those congested sites, it really can